Welcome to this explainer. Okay, today we're going on a totally wild ride. We're tracking this incredibly fast, honestly mind-bending journey. It starts with pure abstract mathematical theory cooked up by a massive venture capital firm, and it ends with a gritty and frankly controversial compromise right down at the level of physical silicon chips. It's the ultimate story of what happens when perfectly beautiful math crashes headfirst into the messy physical limitations of computer hardware. So here's our roadmap for this explainer. We're going to start with Paradigm's orbital AMM theory, then head over to a frantic math retreat in Greece, dig into the actual creation of Orbswap, see why the devs had to suddenly pivot to Rust on Arbitrum stylus, and finally, we'll unpack this massive trade-off known as the FPU gambler. All right, Section 1, Paradigm's orbital AMM theory and the search for a liquid crisis solution. Back in June 2025, Paradigm published a paper called Orbital, and they kicked the whole thing off with this really provocative quote. The future holds 1 million stable coins. Today's infrastructure isn't ready. They were looking ahead at this looming liquid crisis. If thousands of different stable coins actually launch, our current decentralized exchanges just absolutely cannot handle the sheer volume and complexity of trading between them without massively fragmenting liquidity. It'd be a complete mess. Now, to understand the fix, you have to look at the math. Legacy automated market makers, or AMMs, usually rely on these simple 2D Cartesian curves. Think of a messy, tangled X and Y axis. But that math totally breaks down when you want to pool 10, 50, or 100 different stablecoins together. So, Paradigm's solution? N-dimensional spherical AMMs. They basically propose taking liquidity and mapping it onto higher dimensional spherical caps, eventually orbiting them into a torus, which is just a fancy word for a donut shape. This would actually allow for constant time trades across literally any number of assets. But here's the thing, Paradigm isn't just a think tank. They engage in something researchers are calling hyperstition. It's this wild idea of fictions that make themselves real. Paradigm doesn't just go out chasing founders, they summon them. They act like a publisher's clearinghouse, writing the definitive mathematical rules of the game in these white papers, practically guaranteeing that whoever builds it is going to be playing on Paradigm's home turf. Which brings us to Section 2. The Greece math retreat, and taking this from theory to code. Just look at the sheer speed of innovation here. In June 2025, Paradigm drops the orbital white paper. That very same month, a sovereign math retreat convenes out in Greece. And before June is even over, the first working code for a protocol called Orbswap is born. Literally, the theoretical blueprint jumped right off the page and into reality in just a matter of weeks. It is crazy fast. And at this retreat in Greece, the developers did something incredibly clever. To manage the massive state machine of this new AMM, they took higher-ordered time derivatives. These are things physicists playfully call snap, crackle, and pop, and they literally mapped them as physical dimensions. They treated time like physical space. By jumping into 5D, 60, and even 7D dimensions, they allowed for this hyper-precise trajectory planning right inside the liquidity manifold. Moving right along to Section 3, the creation of Orbswap, or the clinical realization of all this math. So the Orbswap team didn't just copy Paradigm's paper word for word. No, they evolved it. They engineered what's called a super ellipse invariant. This specific shape acts as a self-correcting mathematical mechanism that concentrates capital density perfectly. What this means for you is that you can have a massive pool of over 100 stablecoins, and the math just automatically manages the pricing and the ticks. No manual intervention required whatsoever. You can really see the difference when you compare how they track liquidity. The traditional Riemann integration approach is super blocky, it's imprecise, and it really struggles at the body of heavy-tailed distributions. But Orbswap uses polar tick integration. By shifting over to polar coordinates and utilizing angles, the tracking of liquidity becomes incredibly smooth and highly granular. It's a night and day difference. But of course, there's a huge risk when you pool dozens of stablecoins together, right? What happens if one of them loses its peg? Well, the developers ingeniously used their new polar coordinate system to solve this too. Just like holding an umbrella to shield yourself from a storm, they intentionally set up a liquidity position that is exactly 1 degree out of range, paired with a short position right below it. So Orbswap actually mimics a synthetic binary options prediction market. It acts as built-in depeg insurance, hard-coded right inside the protocol. Okay, Section 4, Rust on Arbitrum stylus and how they overcame the EVM limits. Translating all this beautiful math onto a blockchain hit a massive engineering wall. The developers quickly realized that Solidity, the standard smart contract language, was basically like using a broken wrench for this job. It simply lacks the expressiveness for multidimensional trigonometry. Even worse, the Ethereum virtual machine doesn't natively support floating point math at all. So they had to pivot. They moved to WebAssembly smart contracts, deploying via Arbitrum stylus. This brilliant move allowed them to write their AMM in Rust, tapping into Rust's massive, rich standard library and crate ecosystem to actually handle all that complex trigonometry. And that brings us to our final part, Section 5, the FPU Gambler Compromise and the Descent to the Metal. To run polar coordinates and complex trig at blistering speeds, the hardware has to process non-discrete math. And inside your computer, there are two distinct ways to do this. First, you have the ALU surveyor, or the arithmetic logic unit. It is exact, deterministic, but slow. 1 + 1 is exactly 2 every time globally. Then you have the floating point unit, or the FPU gambler. It relies on proprietary silicon to be wildly fast, but it is highly probabilistic and, honestly, lossy. So what exactly is this gambler doing? When it hits heavy math, the FPU essentially approximates it by frantically throwing darts at a board to guess the answer. To do this so unbelievably fast, chip manufacturers burn secret seed tables directly into the physical silicon. Because it's a guess based on a corporate secret, different machines will give you slightly different microscopic answers to the exact same equation. This creates non-deterministic drift. Researchers actually call this the wood chipper effect, because once your data goes through this digital blender, the original data provenance is permanently lost. You just can't reverse engineer a smoothie back into the exact original fruit. And this, right here, is the great compromise of Orbswap. The entire world of Web3 is built around the concept of exact, deterministic, universally verifiable truth. But to actually achieve the magnificent mathematical vision of the orbital paper, to make polar AMMs a reality, the developers had to deliberately choose the fast, unauditable FPU gambler over exact determinism. So I'll leave you with this provocative thought to chew on. We spend all this time and energy building perfect, trustless cryptographic systems in the cloud. But if the physical silicon underneath it all is fundamentally guessing, acting like a hardware gambler that permanently destroys data provenance just to keep up with the math, can Web3 truly trust the system? Think about that next time you dive into DeFi. Thanks for joining me on this explainer. Keep learning, and I'll catch you next time.